Universal constants are physical constants that have a fixed and unchanging value across the universe and throughout time. These constants play a vital role in the understanding of the physical world, and they provide a foundation for the laws of physics. Here are some of the most important universal constants and their significance. The speed of light in vacuum. C. The speed of light is the speed at which electromagnetic radiation propagates through a vacuum, and it has a fixed value of approximately 300,000 kilometers per second. The significance of the speed of light comes from its use as the limiting speed for information transfer in the universe. The concept of time dilation and length contraction in special relativity arise from the constancy of the speed of light. It is also a fundamental constant in electromagnetism and is used in equations for calculating electric and magnetic fields. The gravitational constant, G. The gravitational constant is a fundamental constant that appears in the formula for Newton's law of universal gravitation. Its value is approximately 6.674 x 1011 m/kg, 2. The significance of G comes from its use in determining the strength of the gravitational force between two objects. The value of G is important in astronomy for determining the masses of celestial bodies and their gravitational interactions. It is also used in calculations related to the structure of stars and planets. The Planck constant, H. The Planck constant is a fundamental constant that relates the energy of a photon to its frequency. Its value is approximately 6.626 x 1034 joule-seconds. The significance of H comes from its use in quantum mechanics. It is used to calculate the energy levels of atoms and molecules, as well as the behavior of subatomic particles. The value of H also determines the scale of quantum effects, such as the size of the uncertainty principle. The elementary charge, E. The elementary charge is the electric charge carried by a single proton or electron, and its value is approximately 1.602 x 1019 coulombs. The significance of E comes from its use in electromagnetism. It is used to calculate the electric and magnetic fields produced by charged particles. The value of E also determines the strength of the electromagnetic force, which is one of the four fundamental forces of nature. Boltzmann constant, K. Boltzmann constant is a physical constant that relates the average kinetic energy of particles in a gas to their temperature. Its value is approximately 1.38 x 1023 J/K. The significance of K comes from its use in thermodynamics. It is used to calculate the energy distribution of particles in a gas, as well as the behavior of materials at different temperatures. In conclusion, universal constants are fundamental to the understanding of the physical world, and they provide a foundation for the laws of physics. They play a crucial role in many areas of physics, such as relativity, quantum mechanics, electromagnetism, and thermodynamics. Their significance lies in their use in determining the behavior of particles, the strength of forces, and the structure of the universe.